Hello, we are here for one more lesson of this TFlexCam training course, and the topic for today will be the 2D billing. This is a very important topic, and we have a couple of different types of milling in terms of 2D. So we will do two lessons about this specific topic. In this first lesson, we will see the first two types, the plane milling and the contour milling. And in the next lesson, we will see about the pocket milling and the machining spiral groove. To show you the 2D milling, I have one file open. This is a standard file from TFlex. And as you know already, to do the milling, we have a 2D. We have to create in this milling etches and pads and work on top of them. So we need to know also the positions and the heights of our part. These are also topics that we are going to see later in this course, but these are important concepts. And that's it, basically. So then when you have all those informations, it's simply start doing it. So you know already, CNC menu, we have 2D geometry, so simply go to milling. In milling, you have seen already similar auto menus. So this first type, plane milling, we choose it, and then as we've done before for other types of toolpaths, simply choose one tool file. I have already this one created, the slab. Inside this slab I have two tools, one with 60 mil diameter and another one with 40 mil. So I will choose the bigger one. Basically, this plane milling will create a tool path where I will start to clean my steel block. I'm considering a steel block. Will make some passes to clean my steel box, and it will prepare to do the more fine tool paths. So I've chosen the tool. I can show you this type of tool, a cylindrical tool with some radius in the corners. All of those feed rates, you know them already: rapid feed rates, work feed rates, and the heights for passing to working feed rate. The LOS, I will leave this in 0, it's not very important. Turn on the cooler or not, spindle rotation and the spindle RPMs. And then we reach this part, which is the pass type, and we have a lot of pass types, so we'll try to see them all. So zigzag in X. I will choose my edge, so this, and you can see that I have an internal contour. I will leave it, it's not important for this precise moment. And you've seen already that I have already a contour. Then I will choose the tool lift. If I say absolute, so it will move to the Z5, but I will leave incremental. And if it is incremental, we'll consider the height of the machine planning to position 5 mil above. So I will leave this 5 mil above. I can calculate saying step of passes or saying the number of passes, or also with a more or less automatic calculation for the crest height. I will leave this in one of these guys here, so number of passes. Part parameters, machining plane height. This is the height where the machining should start. So I know that my part, the top of my part, is in Z40, positive measurement. zero thickness, so it will make only one pass, and the step in Z if I have thickness. I don't have any thickness, so simply go and calculate it, and that's it. Machining, you can see, okay, so this Toolpath will simply make a cleaning pass, okay. I can make some variations out of this, like for example, I'm not sure if you've seen this incremental. Let us see it again. So you see I have this incremental here, okay, and in the end 5 mil. If I change this, to absolute, you'll see that the tool will go down. Okay, you see, because now it went to the Z5 absolute. This is not what I want. So in this part, we will leave this in incremental. And in here, I will create more passes. And I will say, I will start in Z50. And because I know that the part will go until the 10 with step in Z of 2, so it will create 5 passes. So let us do it again, machining, and okay, we should have something, the same toolpath, but now doing several passes, because it has, from my parameters, 10 millimeters of material in excess. So very simple, very straight. So this part, it is okay. The steps in Z with the parameters and the allowances. Then I have these offset parameters, and these offset parameters, we can do this in automatic mode or by a value. Is the offset of the contour. If I exaggerate, for example, and say 50, this contour will shrink. Okay, so it's an offset of the contour. Maybe it's interesting in some specific cases. I will leave this 0, and I will leave this automatic mode. Then we have also for the bounds. This is it is used in case of we have zigzag or loop type passes, and with this we will take into account the contours, the inner and the outer contour. So we can turn this on, and now you see that it respects the outer contour and the inner contour. So it's a little different strategy. So not, in my particular case, not very important also, so I will leave this. Offset correction, you know this from other toolpath types, because I have the possibility to correct the tool connecting this to the table in my machine controller. And approximation, in case I have or need circular interpolation, and the precision of that. So everything very easy, just missing the pass types we have available. So zigzag in X, I can do this, and I have always 2 ways to do it, in X or Y. So in Y it will go on the other direction, it's easy to understand. I have the loop also in X or Y, and the loop is a little different because makes go in one way cutting and comes back to the new position in rapid feed rate, in not cutting. We can play this. Okay, it will cut only in one direction. So the same in Y. spiral contoured inside, and this is important. So it will create a spiral. In my particular case, because when I gave the edge, it recognized an internal contour, so it will take this internal in consideration. Okay, but very interesting because it allows to create a more interesting toolpath, taking these contours into account. I can do this also, so spiral contour outside or counter contoured outside. It's the same, but it will cut on the opposite direction. We can do this from the inside. Okay, it's a little different, the moving on the part also. I'm not sure if it will be visible. Okay, this particular case, it's visible that it's completely different, the movement of the tool. The same with this in one direction and on the other one. We can have a zigzag in both directions with avoidance, and this avoidance, it is avoiding the internal contour, and no lift, simply moves to the side. Okay, little different from the other toolpath initially in X. We have also the possibility to do a double loop in X. Let's try this one. A double loop is similar to the other one, okay, but with the recognition of the internal contour also. And I think it's the last, yes, it's the last one, zigzag in X or Y with a straight tracing. This is very similar also to the other one. Okay, but it will make a couple of moves a little different in the middle. Okay, so these are the different modes we have regarding this planar milling. Then we have a second type of milling called contour milling. And the contour milling will create a contour. So the user will give an edge or a path, but basically here functions quite well the path. So if I say, let me choose first the tool file, I will give this smaller one, then the path, I will give this one here. We have the same things here, feed rates, path type, okay, by contour or the opposite direction, so now not very important. The machine plane height, I will give 40. Let's calculate this and see what it does. So on top of the part, simply, it's not making the contour because the radius is not being corrected, but let us change this. So machine height, offset correction is the same. We can decrease the toolpath area, not important here. Radius correction, yes, I want to correct it and I can give a value, okay, 20. So it should be correct now. So play. Now it is correct. In this particular case, because it's a round geometry, it is very interesting, these additional parameters, sorry, not these additional, the approximation, so circular interpolation, and you will notice the difference you see, in the size of the program, so, and much more faster, and with a very good precision, because it was 0.05, yes, it is correct. And basically, this tool type, it is interesting because it is a simple contour, so nothing very fancy, but it will allow you to create something that goes around and respect a geometry that you may have. If you remember, I can have also this geometry. This is a normal entry in this particular case. I can do a click with my right mouse button and say, moving on and off the lead-ins and lead-outs arc. I will not care about what are the parameters here. In this particular case, I think it's counterclockwise in both ways, okay, and it should be yes, okay, very good. This parameter, okay. So I think in this particular case, for these first two types of milling in 2D, we have the majority of the examples done. If you need any additional explanation, contact us, put your questions, and anyway, I invite you to see the theoretical side. We have some more examples and a couple of details that are not mentioned in this video, because we need to keep this video not so long, and sometimes it's already a little bigger than I would like to have the video. Anyway, any questions, any problems, send us an email or put a comment on the comment area in YouTube.